Okay, yesterday we looked at the law of exponents for multiplication. And what we looked at is if you have a to the m times a to the n, you get a to the m plus n. So when you're dividing, you have the same, if you're dividing two numbers with the same base, what do you do with their exponents? Subtract them. And that's what we're looking at a lot today. But don't just think, oh, well, we're not dealing with multiplication anymore. We are dealing with multiplication, but this is kind of our new law that we're looking at more at today. All right, that's the law. I need you to write that down. You're on page 190, and we're going to start with a nice, easy one. And then we're going to slowly build our way to some more complicated ones. So here, the first problem I want you to get is 12x squared over 4x. What is the title of this lesson? Divide a polynomial by a monomial. In this lesson, every problem is going to have at least one monomial. And then it can have any other polynomial. And you're like, well, why do they have to distinguish that? Because you're always going to divide by a monomial. Always. In this lesson, every single one's a monomial on the bottom. But on the top, you can have a monomial, binomial, trinomial, or any other type of polynomial. What do we have right now up top? A monomial. What do we have down here? A monomial. And what do we have all together?
A binomial.
A division problem. A polynomial.
Something important.
What do you have in the denominator?
Oh, a variable.
Can you have that in a monomial? No. This is not a polynomial altogether, but it is a monomial divided by a monomial. Now, it's division, right? But, Mr. A, that's a fraction bar. Yeah, fractions mean division. So please remember that. Okay, this is what we're going to do. I'm going to refer back to multiplication because it really is helpful for dividing for many, many reasons. But here's one reason. This division problem can be rewritten as this. Look at the numerator. I rewrote it as 12 times x squared. Is that allowed? Is that valid? Is that good? Okay, that is allowed. That is the same thing as that, except I put a little multiplication symbol. To rewrite the denominator, I'm just going to write 4 times x. And that is also allowed. That is what 4x means. It's 4 times x. The reason I'm doing that is because when you're actually dividing any polynomial by a monomial, you're really taking it into parts. Okay? Here's your first part. You're going to deal with 12 divided by 4. So what's 12 divided by 4? 3. So all of you should know how to do that. 12 divided by 4 is just 3. But what's x squared divided by x?
X.
X.
Okay, yeah, good. I was like x. Okay, you can say just x or x to the first. Now, how do you know that? Because of the law? Yeah. What was the exponent of that top variable? 2. What was the exponent of the bottom variable? Are they the same base? Were they both x's?
Yeah.
So it's 2 minus 1. 1. So we got that 1 there. And you don't have to write the 1, but you can. That's your final answer right there. Now, you could have saved yourself some time, and this is what my goal is. You get this problem, and you could rewrite it like this, or you can look at it as I'm going to do it right now. You don't have to divide it out to its multiplication parts. You can just say I'm going to deal with this, and then I'm going to deal with that. So what's 12 divided by 4? What's x squared divided by x? So you can do it that way. I'm just showing you how you're allowed to do that because of multiplication. Okay, let's do another problem. Okay, go ahead and write this one. Sorry, Bella, you had a question? That's okay.
Does it matter which way you do it in? Like, can you do the exponents first? And then
Or the variables first, then the number? Honestly, to keep yourself straight, do the numerical coefficients, then the variables. Good question. All right, here's what you're going to be given. Negative 27a to the 4th divided by 9a squared. What kind of polynomial is that? Monomial. What kind of polynomial is that? Monomial. So you have a monomial divided by a monomial. Can anyone write that in as a fraction? Can you guys write it as a fraction? Would it be this? Negative 27a to the fourth over 9a squared. Would it be that fraction? Yes. Do you recognize, just like with numbers, the second number or the second part always goes in the denominator? And the reason I have to say that is because sometimes you really don't do that. You're like, yeah. Second number, denominator. Got it. But how many of you have ever done this? And if you don't want to admit it, it's fine, but I've seen it. And when you get like 4 divided by 12, you get 3. How many of you have ever done that? 4 divided by 12 is 3. I've done it. But what is 4 divided by 12? 1/3. So you got to make sure you put the numbers where they belong. The first number goes in the numerator. Second number goes in the denominator always. No matter which one's bigger or not. And you will get the reverse of this at other times. So don't feel bad. Just put them in the right order. Okay. So I'm going to break it down again because I want to make sure some of you are getting it. I'm going to rewrite negative 27a to the fourth as negative 27 times a to the fourth. Okay, so I just rewrote it as multiplication. And then how do I write 9a squared as multiplication? 9 times a squared. These are nice problems, by the way, to start off with. Very, very nice. Deal with the numerical coefficients. Deal with, in this case, the a variable. That's nice. They don't always stay that nice. Okay, what am I going to deal with first? Negative 27 divided by 9. What's that? It's negative 3. You know how to divide that out. Negative 27 divided by 9 is negative 3. And then what is a to the fourth divided by a to the second? A to the second. Because these two are being divided with the same base, you do what with those exponents? Subtract. Now listen, it's always top minus bottom. Always. Mr. Ray, but what if it was 2 and 4 switched? Always. Yeah, and you'll get a negative. Not today, but definitely tomorrow. This is my answer right here. Negative 3a squared. If you didn't want to rewrite it out, this is how you would have done it. You would have dealt with these two, and you would have dealt with these two. Same answer. Okay? Any questions so far? How many of you think this is kind of pretty straightforward? Good. It is. It is straightforward. Go ahead and write this as a fraction. You can go ahead, just go directly to a fraction. Okay? Wait. Can it? It's not a fraction. It's a division problem, Mr. A. You must be confused. All division problems can be written as fractions, which means that all fractions can be written as division problems. It goes back and forth. Okay. I'll start with white. Oh, but Mr. A, isn't 24 bigger than 6? Yeah, that's true. So should you switch it? Switch these around? No, it's a different answer. What's 6 divided by 24? 1/4. Leave them as fractions. Don't go decimal here. I'm going to deal with it. 6 over 24 is 1/4. I just simplified that. What's d squared over d? D to the first. And you could just write d. And then what's e to the sixth over e to the first? E to the fifth. Yay. So can you get fractions on these? Yeah. So you will get fractions. Not all of them, but you will. So far, so good? We're good? It's my duty. It's my duty.
Wrote it as a decimal?
Yes. Today you will. And I'm trying to save you some trouble because some of them are not nice decimals. Uh-oh. Oh, Mr. A, this is like any other problem. With one little difference that can cause a lot of trouble to people if they're not careful. How would I write this as a fraction? But you can write that as a fraction? Yes. Just like you did the other ones. Help me? Help? Yeah, Emily?
Negative 16 r s to the second t to the third over negative 16 r t to the second.
All right. Yep, that's how you write it. That's a fraction. Okay. Okay, looking at this right here, what I'm going to do to help some of you out, because some of you are like, wait, do you remember the other problems we've dealt with? You've had, like, for example, you have a on the top, a on the bottom, x on the top, x on the bottom, t on the top, t on the bottom, for example. What's different about this one? You have r on the top, r on the bottom, t on the top, t on the bottom, but you don't have s in both. So here's what I'm going to do. Negative 60, that's not it. Negative 60 times r times s squared times t cubed. I'm going to go back to this to show you that we're not making stuff up. I'm not trying to trick you or come up with some new thing. In fact, I did some thinking today, this morning. I was driving. I was thinking about this lesson as I was driving to school. I'm thinking about, this can get so tough for people because we start not knowing what's going on here, and then we forget what laws govern that, blah, blah, blah. And then I was thinking, wait, go back to the properties. Yeah, have you seen those movies, go back to the beginning? And so I go back. I go back all the way to chapter 1. I'm thinking in my mind, properties. This is a property being shown. This is a property. That's a property. That's a law. I'm using laws. Go back to the basics, and these problems don't get that hard. And that goes, I'm tutoring algebra. I was tutoring this Algebra 2 student, and guess what I was thinking of? Properties. And a little bit of this for some of the problems. Yep.
Can variables cancel out?
Yes. Yeah, and we're going to see what happens. All right. Then I'm going to rewrite this as negative 15 times r times 1 times t squared. That 1 just popped in, right? Is that allowed?
Yes.
Because of what property? Sorry, I heard identity, right? And you're like, okay, yes, you could put a 1, but why would you put a 1? All right. Can I deal with this? Yeah, what's negative 60 divided by negative 15?
4.
Positive 4. All right, what's r divided by r? Cancel out, but what does it actually equal? 1. What's any number over itself? 1. And then here's where some of you didn't believe me at first when I first brought this up 7th grade. Maybe you're still doubting me in 8th grade. Isn't it r to the first over r to the first? What's 1 minus 1? 0. So what really is r to the 0 power? 1. So yes, they cancel out. Why did I put a 1 under s squared? Because I did not have I didn't have an s variable here. But what is s squared divided by 1?
S squared.
Oh, so it's just s squared. You just leave it alone. I did that to keep things parallel, and I'll show you how you don't have to do that, but there is a reason why you could just put the s squared there. Nothing happened to it. And then what's t to the third over t to the second? T to the first. And you just put t. That's your final answer. That's a simplification. And again, here's how you do it if you don't want to write all that out. You could deal with this. You could deal with this. And then this is why I wrote it out a little bit, because this might confuse people. You can deal with that, right? So what do you do with the s squared? Leave it alone. It's s squared, so it stays as s squared. Okay, you guys okay with that? That's the tough part so far. Yes, ma'am?
What if you have the s squared was on the bottom and there was no s squared?
Ooh, actually, thank you for bringing that up. Let's say s squared was on the bottom with nothing up top. So in my answer, where do you think s squared should be? Or what is 1 over s squared?
1 over s.
1 over s. So if that were the case, this was down here, there's no s, you would have 4t over s squared. You leave it in the denominator. Yeah, it's a fraction. For now, today, the next few hours. But when I see you guys next, Lord willing, if I see you guys tomorrow morning, we're going to have to do something about that. because I don't like that.
We don't see small numbers.
Yeah, what
Ooh,
if
you should
we're
come to the
or
hospital.
you yeah, we covered the hospital.
Well, I never thought about that.
Hijack the elevator and make people pay for it.
Yeah, that's exactly what I said, because I don't know. I don't know what's going to happen tomorrow. I hardly know what's going to happen after this class. I hardly know what's going to happen during classes, to be honest. All right, go ahead and work this problem out real quick. Just you do it on your own. This technically comes from page 191, and this was number 2 on the try these, but I want you to try them. You do it on your own. Just be very careful, because just like with multiplying, the variables mean something, those exponents mean something, and if you do the wrong operation, I'm sorry, it doesn't come out to the same thing. Okay, you should have had this in your mind, not writing it out. Okay, this is what you should have. And I'm going to deal with the 9 and the number down there. What's that number down there? 1. So what's 9 divided by 1? 9, good. And then what's a to the 4th over a to the 3rd? Yeah, a to the first, good. What's b to the 3rd over b to the 3rd? B to the 0, which equals 1, so you can leave it alone. And then c divided by 1, c, so 9ac. 9ac on that? How many of you can do that? Okay, every problem this afternoon has been a monomial divided by a monomial. And every problem today will be divided by a monomial. But will you always be dealing with a monomial first? Dramatic pause. No. Write that down. Put a little asterisk by it too, because I'm going back to fractions. Oh wait, I already dealt with fractions. Okay, anyway, I'm going further back to fractions. Okay, a plus b over c. This is a fraction, and by the way, you've dealt with this a lot, more than you thought, more than you're probably thinking about. What kind of polynomials in the numerator? Binomial. A plus b is a binomial. What kind of polynomials in the denominator? Monomial. And by the way, what will all your problems in this lesson have in the denominator? Monomial. What could you have in the numerator? Monomial? Binomial? Trinomial? Yeah, even. Wait, yeah. Trinomial, and then you can also have 4, 5, 6 terms, but that's later. A few minutes. A plus b over c can be rewritten, and I'm going to shock some of you, but you shouldn't be shocked because you've dealt with this too many times. A divided by c plus b divided by c. It's a shocker here. Uh-oh. Sorry, a plus b over c. That plus is a critical thing. Now it's 2 fractions. Ugh.
So now it's AC.
Now Mr. A is just being mean to us. Okay, ready? It doesn't mean too much with letters. I mean, it's like, whatever. Let's deal with some numbers. Can someone give me some values for A, B, and C? Not too big, no negatives. Just go easy.
1, 2, 3.
1, 2, yeah, 1, 2, 3.
Yeah, 1, 2, 3.
A, B, C, yes.
3, 5, and 4. Thank you. Okay, A is going to be 3, B is going to be 4, and C is going to be 5, okay? Right? C is the same thing, so C is the same thing down there. All right, ready? You have 2 fractions, and you're adding them. Can you add them just the way they are? Yeah, you can, because they have common denominators. When you're adding fractions with common denominators, all you had to do was add the numerators and put it over the common denominator. Isn't that what you had to do? And then you would simplify that, and you get your final fraction. So have you done this before? Yep. You can take 2 fractions and combine them into one but make sure that you realize that there is a sum up there. Like there's a sum, and that's technically a binomial. Okay, but anyway, you guys get that? It's not you. I'm not making stuff up. I don't want to make stuff up because my imagination can go out there and I could be dead wrong. So I'm trying to use stuff that we've looked at in the past. What does that mean for us? Uh-oh.
But this last one,
That's not
is this the polynomial?
I wasn't very trying to do it.
Okay, write this problem down. Divide this by that.
Do you divide everything by 4?
You're getting there.
Everything by 4.
Okay, so please remember, this is the problem they write for you in the book. So in your homework, they're going to say divide blah, blah, blah. So you don't have to write this every time. This next step that I write down is what you can write down. Okay, this is a division problem. What kind of polynomial is first? Trinomial. 1, 2, 3. Divided by a monomial. The whole lesson's about dividing by a monomial. Okay, so I want to write it as a fraction. Who can write this as a fraction? Chelsea.
I did 8x cubed minus 12x squared plus 20x over 4x.
All over 4x. Okay, that's the fraction. That's what it is. If you have a trinomial over a monomial, you can actually split it into how many individual fractions? 3. Go ahead and do this. 8x cubed. Is that the first term? And you're going to put that over 4x. That's one fraction. What's the second term? Negative 12x squared. What should I put that over? 4x. And then the last term is 20x, and you're going to divide that by 4x. I'm going to change this just a little bit. Okay. That's all I did. I broke it into 3 fractions. Yes?
Does the 20x over 4x, does the x cancel out?
It will.
I just,
That's okay. Yeah, no. We're going to get to that. Yes, they do cancel out. Now watch. Mr. A, this is not what we've done before. This is what we've done before. Look at it. Have you dealt with this problem before, this type of problem before? Just this right here. Yeah, you did that on the other examples. Now you just had to deal with it 3 times. And since you're so good at it now, it shouldn't take you that long. Right here, look at the first fraction. What's 8 divided by 4? 2, yeah. 2. What's x cubed divided by x? X squared. Because you did 3 minus 1. That's 2x squared. That's what you did in the other examples. You did it 4 or 5 times now. Now you're doing it for your 6th time. Okay? What's negative 12 divided by 4? Negative 3. X squared divided by x? X. You did that now for the 7th time. And then what's 20x over 4x? Positive 5x to the 0, which is 1. That's your final answer. Oh, yeah. Oops. Did I say it was going to be bad? Did I kind of make it seem like it was going to be bad? Actually, it was your classmates, wasn't it?
No, it was you.
Were they? Who said what? Did your classmates, from your fellow 8th graders, did anyone say it was hard?
No.
They said that.
Comrade flirting.
All right, comrades.
Party for
Oh, wow, you're cheering for this. Okay, page 191. Try these. I want you to do number 5. On the very bottom. Very nice.
On page 191.
Yep, page 191. On the very bottom says try these.
So just go ahead and do it by
Number
separate things.
5.
Yes. Yep, you can separate them. But actually, Braden, can you read that problem for me?
4xy cubed plus 3x squared y to the 4th plus y
thank you.
You're welcome.
So that's the problem they gave you. You don't have to rewrite the problem if they gave it to you like that. But someone said, can I just divide it into their or split them up into their fractions? Of course you can. And this is how I do it. You may want to do it separately because the way they write it in your book is kind of small, but I just do this. I just write that monomial underneath each term. This thing?
So is the second term going to end up being
Yes. And you can get fractions, and you will get fractions on at least half of them. So, on your homework. All right. So, who can give me the simplification of the first term divided by 4y squared? 1xy. Okay, so the 4's became 1. X stayed the same. Y to the third over y squared is y to the first. That's your first term, xy, or 1xy. I'm good with either. Second term. Who can give me the second term? Yes, yes, yes. Bella?
3/4.
Plus 3/4.
X to the second.
X to the second. Y to the second. Yeah, because you have y to the fourth over y squared.
Oh, I put
Okay, that's right. Yeah, and just like yesterday's homework, the variables count and those exponents count. And so if one of them's written down wrong, it can mess you up. Okay, and last term. Braden? Plus 1/4. Whoa. Okay, y squared over y squared is 1. Is y to the 0, which equals 1. All right, so that's your 3 term. How many you got that one? Oh, Bella, it's like, do you guys ever watch those shows where someone's like presenting something and they actually plant people to ask questions? So I paid Bella to ask me that question. What was your question?
Can there be negative?
there cannot.
What if there are negative exponents?
You make the number negative the exponent.
So look on page 191 and look above at where are you?
Number 3.
Those, do you see those examples 1, 2, and 3? Actually, those are a little more complicated. Oh, let me just give you a problem. I'll just give you this. What if you had, so you don't have to write this down, this is what we're doing actually tomorrow. So Bella, this answers your question. What if you had a to the third divided by a to the fifth?
-2.
You would get a, what's 3 minus 5? -2. It's just a to the negative second. Now, if you wanted to rewrite it so that you don't have negative exponents, because that gets tough. Okay, we said this maybe a week or two ago. When you see a negative exponent, you think
It's not right.
reciprocal. Anyone know the reciprocal of a over negative a to the negative second? 1 over a squared. We're about to prove that tomorrow. That's why I don't want to get into that because it's just a little bit too much. All right, we'll get to that. We'll prove it.
Oh, man, Mr. A.
Last problem, then I'll give you your homework. Sorry. Oh, whoa. Surprise. No. No negative exponents on your homework because we haven't covered them completely, so. Oh, that's right. I only need 15 of you to get this one right. Come on, guys. It's Tuesday. It's Tuesday. I wanted all of you to get it right, but we'll go easy. Okay. Hope you get it right. Oh my, oh my. Please write the problem down correctly because, Mr. A, I wrote, instead of a 5, I wrote a 6. Well, you did everything you wrote down right, but it's the wrong answer because it wasn't written down. And trust me, I've done that before. And it's not very nice. When you did it, you worked out this problem, you did the process correctly, you got the wrong answer. It's sad. Okay, I'll give you a minute and a half. And don't be afraid of fractions. And keep your exponents straight. And don't forget the law. And don't forget that's kind of multiplication. And remember fractions. And okay, just do all that. Just remember all that. You're fine. Oh, you got it? Oh, bold. Me. 15 of you actually. So I got 2, I think 3, 4, 5, 6, 7, 8. I really do hope you get this, guys, because if not, I add a little number to this denominator.
You had an extra page?
Yes.
Did you want to problem? The homework page. What page?
Maybe. Okay, anyone still working? Anyone still working? Go ahead, keep working. 30 seconds.
Here, Max, you got them, boy. I'm done.
Thanks,
Comrade Glory.
I'm guessing you talked about Marxism.
Yes.
In communism.
But we're not communists. We're just comrades, Mr. Ed. Yeah, we're not. We just
Captain
like calling each other
Communism.
comrades.
Like communists do.
Yeah, like communists. Like, we're the capitalist comrades.
Yes,
You just made enemies out of both sides.
Comrades from Mexico. You went to the hard cover.
Okay, here's the answer. Check your own. Be honest. So this was it's technically number 6 on the page. 3x squared y cubed minus 2x to the 4th y squared minus 4. Now, did 15 of you cheer or not? Raise your hand.
Comrades, you win, guys.
Comrades for life, boys.
15 of you. Okay, good job, guys. So because you got them right, I'm doing this. I'm stopping the lesson, and I'm giving you. Please go in your workbooks. So turn in your workbooks, please, to page 181. It's different because I'm not giving you odds or evens necessarily. I'm not giving you all of this, so that's why I have to say it differently. 181. And get a pencil out because you're going to circle the problems that I'm going to tell you to do. Not all of them. Because I want to skip the negative exponent ones.
Why did it say true?
Excuse me? Oh, and the number 1? I'm not going to have you do this, but all your answers can be checked. And it's fascinating. You know how you divide 12 divided by 4 and you get 3? How do you check that answer? 3 times 4 equals 12, right? So you kind of work backwards. These problems can all be checked the same way. You can check every single one of them and see if they're right or wrong, but I don't want to bog it down with that one. Okay, so you're going to circle number 3, number 4, number 7, number 8, and number 9. I can give you more. You guys want more? No? So number 3, number 4, 7, 8, 9. Bye, Swivel.